Hey everyone, thank you very much for coming to our talk today here on Exploring Advanced Volatile Memory Analysis Challenges for Fun and Profit. So here are some things to expect in today's presentation. I'll wave my hands a little bit. We actually have a video of a live or the demonstration on how to utilize the tool, and then hopefully time will afford that I can answer some questions at the end. But just a quick disclaimer, the views and the information presented in this presentation, they're that of me, they're that of the presenter, and do not represent the views of the United States Air Force or the Department of Defense. All right, here we are. So book reference. So here are a few book references that I built off of in order to create this research, as well as additional workshops. I lead workshops on how to do this for free, like free workshops. And then I point to references. So if you are interested in exactly what I'm talking about, here are some of the books to get started with. All right, so as you heard from the bio, just real quick, who am I? In essence, I love to do cybersecurity, and I love to help other individuals on how do we better secure our systems. Sometimes that will come from a defensive tool that I'm happy to release. Other times it comes from an exploit tool that I'll develop to show like, here's a problem, and then we can talk about how do we secure this in order to better defend our systems in the future from actual malicious actors. Okay, let's get into the research motivation. So the research motivation, the main thesis on what I do in my research is that premise that malware continues to increase in sophistication and prevalence. There was a research that was conducted by the RAND organization here. It was done around 2014 or 2015. And what that research identified was the average lifespan of malware, different than what our antivirus vendors will tell us. And this is not a hit to our AV vendors or our security teams, but they identified that the majority of the 0 days that was 1 to 0 day that existed on the machines in the wild, the average lifespan of malware was actually between 6 and 7 years of life until it was detected and then remediated from the victim machines. And even today, we are seeing that AV vendors, they're getting very, very good at identifying malware, but many of the results or reports that I am seeing whenever a new malware has been detected, that malware has been present on that system or the network for years before they've been detected. So clearly, we do have to continue to increase our abilities at detecting and mitigating from malware types of attacks. And the most important thing here on this slide is to understand that although malware gets really good at hiding itself from the operating system and from the network, malware, one place malware cannot easily hide is in memory. That at any point, there should always be a trace that we can see like, this might look nefarious, let's investigate further, which can lead us to that malware attack. Right, let's go into the memory analysis artifacts that we can extract. Now here, I use this to show that there's memory, volatile memory carries lots of artifacts if we know how to extract it from the computer system. Now, I just like to show this as this is just a few artifacts that we can bring out. One, I would definitely use this memory analysis as I'm doing like reverse engineering. If there are packed or encrypted samples that I'm not able to analyze statically on my machine, there are times that I can just run it, launch it, let it execute for a while, and then dump it from memory in its unpacked, unencrypted form, and then it can allow me to do better analysis from that standpoint. I like to use memory analysis to extract the master file table and lots of prefetch information to just give us a wealth of forensic data of what happened on that system, when, who are the initiators of various attacks, and lots of other details here as an exercise to the expert. You can spend some time looking through these and then working on this on your own time. Okay, let's go into the malware analysis triage process. So I created the malware analysis triage process, or at least a pictorial representation of what I always do whenever I conduct analysis on various machines. I see that I always, I usually start from physical memory or at least a memory image. This is part of our data acquisition process. And now as we go on our stack, the data conversion goes upwards. We start from the raw data, and then we begin and we utilize various aggregation routines and extraction routines in order to pick out various forms of data. And then I analyze those data into respective pillars. But something I find is anytime I'm looking at this analysis, I always want to know in general, what is the status of the system? what processes are executing on the computer machine, what files are present, what modules might exist, DLLs, injected DLLs, legitimate DLLs or drivers on the system. What is the network activity? Perhaps this can lead us towards malicious activities occurring on the system, or what type of caching information can we extract, like registry information in the memory, or that master file table prefetch data, like what can I bring out from the system? And then I go into additional analysis in order to produce knowledge about that system. That knowledge allows me to create a report. It doesn't have to be a fancy report, just something to annotate. This is what we learned from this system in which we've gone from the physical into something that we all can relate to and understand what's happening on the system. Okay. Here I'm just doing a quick tools of the trade in our acquisition process, to our analysis process, into our reporting process. There are many tools that can be utilized. The ones in red are what we focus for this research. And so magnet RAM capture, that's one of the really well-known tools that have been quite stable, in which I can launch the tool to give me a dump of the memory. Then I can utilize different analysis routines to understand what are the artifacts on the system. Volatility is a well-known memory analysis tool. And so I built the Xavier Memory Analysis Framework on top of volatility in order to extract data, and then I analyze it, and then we produce a custom report for us that we can see what are the details of this system. Okay. With that information, let's go into a challenge problem to help guide how to utilize this tool, and then what we can use or learn from in this new advanced analysis construct. So allow me to introduce you to Memo Labs. Memo Labs is an educational suite. It's a capture the flag exercise of 6 memory images that have been dumped and provided to you in order to test, as well as enhance your ability to conduct memory analysis. We will utilize this as a foundation to learn from, and then see how can we enhance this analysis process. And so we will get started here with Memo Labs version lab 1. And then the handle of the individual who created this is Stuxnet 999. And so if you have time, please check him out. He has good work out there. And so that's why I thought this is a great way to start in our memory analysis process. So here's the challenge problem. In a nutshell, there is a computer, your colleague's machine or your colleague's sister's computer, it crashed. And now at the time of the crash, she was working on a paint program. And so our role or our task in this investigation is to figure out what happened, what programs are unique in this computer and at the time of the crash, and then what systems, like what files relate to each other that can lead us to solving the challenge for this specific capture the flag exercise. And again, we're using this for Memo Labs lab 1. And at the bottom here, with that question mark, I'm showing that you can go directly to his GitHub to download these memory images and then conduct your own investigation and follow us along with what we're doing. So here are some helper tasks. So I created these helper tasks to help guide us towards this type of challenge. And so overall, I just want us to see how can we build that tool to help in the data extraction process to solve this problem. So these are the main questions that we'll go after. WinRAR is something important that I want us to find. Let's go ahead and look into how does WinRAR relate to this system. And then down here, I'm actually telling you up front, these are 2 suspicious files regarding this investigation. Important.rar, as well as this stage1.bat file. So I'm telling you, like, hey, I want you to find these, but how do you find this efficiently? And we'll, in our demo, we'll see how do we solve these tasks. Okay. So if we look at our memory analysis, solving this type of analysis requires a lot of data. And so on this side, I'm just trying to show that these different plugins from this volatility tool can be utilized or kind of consulted for further analysis to figure out what's happening and then solve the problem. But now, if you've ever done this before, I want us really to appreciate the difficulties of conducting memory analysis at present time. And so here we are. The current method of doing memory analysis utilizing a tool like volatility or very similar, it is highly data intensive. There are lots of data that's going to be extracted first from the machine, and then we have to spend time analyzing this data one by one to begin and annotate our notes to figure out, well, what happened here, what happened there. It takes a lot of time. And if you've ever done this before, you'll appreciate that this is what it looks like on our side whenever we're doing the analysis before. But now I want to introduce you to my man, Albert Einstein. So something Einstein said is everything should be made as simple as possible, not just simple. And so in memory analysis, I'm trying to make this as simple as possible in order to help us conduct various analysis, as well as solve challenges as fast as possible. So in order to do this quickly, I want to introduce you to a few concepts. One of them is this concept of the aggregate plugin. So what I do at the beginning of the presentation, we spoke about those various pillars that I like to kind of arrange my information into whenever I do this type of analysis. So one of this aggregate plugin is a process. In Volatility, I can utilize multiple plugins and then aggregate that data into a single frame called process. And now you as the expert, you should be able to go to one spot and say, what is the information about processes on the system? And then all the data should be there present for you. And then we can enrich our analysis from that standpoint. We also have a concept of data extraction or data cross-referencing. And so then the data cross-reference allows us to see, like understand the context of how is an artifact utilized within this memory system. So it's not just a search, like a grep for a keyword, but now I want to see what processes, what drivers, what modules are utilizing this keyword, and then how does it relate in the entire memory system? And you'll see an example of this data cross-reference in our demo to come in just a couple of minutes. I lastly want to talk about a system manifest. And so we can utilize this concept of a system manifest now to distill all of the data that we see in a multi-gigabyte memory image. We can distill that down into a few megabyte file to now allow us to replay an analysis, save hours of investigation. And then we can also do this thing called a snapshot analysis to see the difference or the similarities and the differences between a non-compromised system as well as a compromised system, and then let us compare these artifacts directly from memory. Now, this is very, very useful whenever we're investigating an infection similar to like Metasploit or Interpreter on a system. We can now follow and see when that Interpreter or Metasploit, a system is compromised, and now the initial compromise or that binary that's malicious or the models that are utilized in that investigation, when it migrates to another process, we can actually follow where it migrates to. We can identify this because we've seen the changes in memory, and then we can aggregate this data across the entire enterprise to better find malicious samples based off of new heuristics just by analyzing them. So this is a pictorial representation of what that Xavier construct looks like, and we'll get into that into the demo to come. And then let's dive right into the live demo. All right, let's get started into the live demo portion of this presentation. Now, this is going to be a very, very high level. I'm going to go quickly so I can show you the main portions and the outputs of this tool. And as an exercise for the experts, on your side, you'll be able to spend a lot more time in this tool, as well as follow other tutorials that we have to get you further acclimated with this program. So everything begins by going to my GitHub, github.com, Solomon Sonya, and then we'll go ahead and click on Xavier Memory Analysis Framework in order to see where to get the most updated versions of this tool, as well as all of the source code that I provide fully open source to everyone who would like to conduct this type of analysis. Now, once we come to GitHub, we'll click on binaries, current version, and then we'll download the updated version here. So right now I'm working on version 2.309. And so once you download this version, I will put it into my own folder called Xavier, and then Xavier, and here I just named it version 2.309, just so I can ensure I'm working on the updated correct version of this tool. Now, the first time you launch the tool, it will ask you for two things. The first thing we'll ask you for on the Windows side, this right now mainly works on Windows machine for the full features. And then once I'm done by version 3 and so forth, that's going to work on cross-platform compatible. Again, always open source on Unix as well as any version of Windows. Okay, so once you open this, it will ask for the volatility tool on the Windows side. So here, if I go into the framework, I click on import memory analysis. This is where we'll place the volatility framework, the volatility tool that we can download for free. And so we download that, we place it into the import memory analysis folder. Memory image, this is the folder that we place our Mem Labs Lab 1 raw image dump that we want our tool to analyze. So I'm going to place that here in import memory image, Memo Labs 1. Then there's also a setup.configuration file that is present here. So in setup.configuration, this is where we can direct the tool to execute various functions for us. Now, the three main ones that we're going to focus in this presentation are these lines that are, please, keep these uncommented. So here, the first thing that we'll specify is our investigator name. So I'll name something. For you, your investigator name. Then investigation descriptions, this is where you can give like a line, a description of what is the type of investigation that we are conducting. Right now, I'm just going to keep it short and say Memo Labs 1. And then the profile. The profile is required on volatility that runs on Windows machines. And so here I'll specify Windows 7, Service Pack 1, x64, the specific profile required by volatility. Now, once we launch the tool, I'm going to double click the tool, and then the tool will launch here, and now it's running its setup. So it's running its setup, it's looking at the volatility tool that we specified at this side, and then it will give you some prompts here that it's waiting to understand what the plugins and the parameters of this volatility tool looks like. And then when it's complete, it will show you the options and the plugins that you can specify if you want to run plugins individually. You can also click on the search and then search for a specific plugin that you want. Like in my side, I want to say, hey, let's talk about NetScan, network scans of this image. So if I click here, I can now search and specify, or I can click on everything, and then I'll specify analyze if I want to analyze these plugins individually, as I said. But that's the old tools or old capabilities that existed in this tool. What we care about here is the advanced analysis side. So advanced analysis automation, if we come here, the thing to click on is initiate advanced analysis. So if I click on initiate advanced analysis, I'm going to do it so you can see what it's going to look like on your side. Once I specify initiate advanced analysis, leave your machine to execute all of the respective plugins for 20, 30 minutes or so. On my side, it's going to take a little bit. And so on my computer with this configuration, it takes about 30 minutes to analyze a 1 to 5 gig memory image in order to produce the output reports that we're about to go through. So I'm going to fast forward here and say, okay, we just completed something right here in a couple of seconds. Okay, the halt is going on. Okay, good. Okay, so I said the reason I'm halting it is because the analysis takes a while. Let's fast forward 30 minutes before the analysis has complete. Another thing that this will actually provide a good demonstration is, let's say the next day or so on, you want to replay your analysis where there are, or the benefit of this tool is I put in 2 import functions. And here you can import a previous analysis, a complete analysis directory, or you can import a manifest file, which is a single file that distills an entire memory image. So instead of always having to transfer and reload a multi-gigabyte memory image for the analysis, you just load a few megabyte file that describes everything, and you'll see this here in a few minutes. Okay, so what I want to do after I've completed the analysis here, whenever you do initiate advanced analysis, if this is the first time and you complete your analysis, you don't need to do any more imports. You just look through the report and you continue on. What I'm doing is I'm showing you, let's say you shut down the tool and now you want to restart, or you shut down the tool and you sent the data to somewhere else. This is how you reload your previous results so you can continue forward in your analysis. So I'm going to go to File, Import, and then you can either import the system manifest file, a single file that's located in the manifest directory. I'll show you in a few moments. Or you can import an entire analysis directory. So I'm going to do the entire analysis directory just so you see what the analysis looks like once again. So on this side, I'm going to go to a previous analysis that I have completed previously. Okay, so that's going to be in the export folder. So remember, imports are what you want the tool to analyze. Export will be the outputs that the tool provides for you. So in export, memory analysis, and then there are dates of when the analysis and a timestamp of when the analysis was first initiated. I'm going to click on this one that I completed a couple of days ago so you can see all the results for us. There are a few folders to really care about. And I'll show you that in a moment here. But at this time, once we go to the right export folder, click Open. And then the full analysis will be conducted here, and then it will provide the results for us once again. Okay. Now, saying the export folder, what does it look like inside? Okay, I'll show you. So if I go into the folder, the two main ones that you really want to care about will be the HTML export as well as the manifest. So I spoke about the manifest. The manifest is a single file that distills all of the data from multi-gigabyte memory image. It distills it down into a few megabyte file. And this is what we can transfer to any other system to be ingested by another ingester or to be reloaded into this tool. So now I can recomplete the analysis and save, hours of investigation that just replays exactly what we've seen previously. Okay, so the HTML. The HTML is where the report will be provided for us. So if I click on that, analysis report, this is the HTML file. You'll see particulars about the investigation that's provided at the top side. And then there are three main sections within this export file. There are the graphs that we can have semi-interaction with the analysis results. There are tables that produces not graphical, but tabular data about the analysis. And I'm showing you really quick because there's only a short amount of time for this demonstration. But if I click on, let's say, tables, for instance, here I'm in the process information. So every process that was discovered in this tool, I can click on that. And then it shows me in a tabular format all of the details about each process. It's in a single line. So this provides better details for us to see all of the data at one spot. There are a few things that each of these tables do for us. At the top, if I were to click on any one of these, it will also sort for us. So I take your feedback. A previous expert asked, hey, I want you to be able to sort the data so now it can be easier to go through and analyze in this table format. And I did that for you. You just click on any one of these and it will sort for you. A few also things that should work most of the time, there are pivots. So if I click on usually this will work, also enhancing the plugins in the interface with VirusTotal and other behavioral analysis engines. But for instance, if I want to pivot directly into VirusTotal from what we've seen here, we can do that. And usually if I click on a specific process at this side, and I click on the link, hopefully it should pivot us directly into VirusTotal. So this one was not found. But some of these images, let's try this one. Some of these images like this specific link on this tool, if I just clicked on it here, dump it, clicked on the link, it should pivot us into, sorry, not that one, this one. It should pivot us into VirusTotal, and then we can further analyze what other individuals have seen across this sample. And then, usually your red is really, really bad. The more red that we've seen. This dump it tool, this is a tool that could be used maliciously, but generally practitioners, we use this to procure an image of the system that we want to analyze. On the right side, we also have other pivots here that you can go directly into the virtual address descriptor tree. We don't have time to talk about this, but that's just ways that you can interact with the details that are provided here in the tables. Let's go up to the top. Let's take a look at some of these graphs. So this graph shows us the process tree. And here we can kind of expand to determine like what is the call tree of each of the processes in the system. Graph viz, we showed you in one of the imports previously, or we spoke about it, that, let me show you. In the import directory, we should have said the memory analysis, we place volatility, memory image import, these two come in here for analysis. And then packages, here graph viz, we download the graph viz package, we can place it into the import packages, and if that is provided and present for us, we can, Xavier can interface with that in order to show us or to produce this graph for us automatically. That's just your call tree here. Now we expand that concept into creating the process information tree. And let's go further into the system information tree. So in this system information tree, this gives us all the information that Xavier was able to analyze into the respective pillars that we were talking about previously. So process, your network information, your caches will be down below, and other details. You can expand this to determine further. But what I want to click on here, processes. This is the tree of processes that are present inside the system. And then we can dive down even further. So WinRAR is one of the tools that we spoke about that we want to look into. I also want to show you one quick feature here, and then we'll continue forward. On this side, you'll notice on every one of these frames, here there is a relative link to a bigger table here that we can look at, or bigger graph. So I can click on any of these links, open in a new tab, and then what that will do is it will give us kind of a cleaner view that I can further interact with just that details that I was looking at previously. So if I expand my processes, I can see all the processes in the system. I want to look at WinRAR at this side here, because what we specified that, hey, let's go ahead and look at this specific process. I like to look at the parent process relationship, the sibling process relationship to see other processes that were instantiated by the same tool. This is also really good in looking at, peradventure, you're analyzing a ransomware type of tool. So looking at the sibling process can help us identify other processes that could be utilized for persistence, which can kind of speed up our analysis even faster. Okay, so as we're looking through this, file attributes, if I go into the process information, this gives us lots of details about that single process in a single instance. I can see the command line. We also specified that imports, important.rar is one of the processes we want to look at. Here, this tool already shows us that, okay, let's go ahead or these are command line particulars, parameters that were specified in this analysis. There are lots of other areas that I want to expand, but I only have time just to do a quick overview for this tool. But as an exercise to the expert, take a look at these things to become more familiar with the output that is provided for us. I want to pivot back into the tool set. So one thing you did see is I talked about command line. What are the command line parameters? So important.rar. Let's say we want to search further about this specific artifact that we found, important.rar. If I come into the tool here and I click on my data cross-referencing side, I can do a search on anything that we discussed before. So if I say important.rar, because I want you to look at important.rar and determine what is the context of this artifact. Here, Xavier is searching everything in the tool set. I can see important.rar is utilized by this process winrar.exe. There's a command line argument to that, which we saw previously on the graph, important.rar. There's also an indication in a separate plugin called file scan, which tells us not only is that file present or are there hits to that file, but we can also extract details of that file right here. And I'll show you at the right side. So if I look on the tool and other searches that we like, we can also include Yara search string. So if you want to do Yara search string, or there's also a way to include Yara signature files. So I was talking to another analyst and he said he always likes to do specific searches for different malware signatures in every memory image. And so he wanted an easy way to be able to do those searches using this tool. I said, okay, no problem, I got you. And so I included that feature here that if you have a Yara signature file, you can specify that, do a search, and then it will use that signature file as well to enrich your searching. But what I wanted to show you is at the right side, if a file is present, then this is really, really cool, that without even having the hard drive, if it was present in memory, we can see how to dump that file. So what I want to do here is I'm going to click on file scan, and then if it's found, I'll click on file scan and then say dump selected file. So I click on dump selected file, a separate plugin is going to work and then show those details for us right here at the side. Now, another file that we wanted to show you from this investigation was that stage.bat. So if I bring that back right here, we said, hey, what are the details or contents of this stage.bat file? So I'm going to take that, and then let's also search for that as well. This is our data cross-referencing feature. So if I do my searching, oops. Oh, sorry, I specified include Yara signature file. That's why that showed. I don't want to include a Yara signature file in this searching right now. So what I want to show here, actually, is once we've done that searching, we see that yes, there is a hit for that specific indication. Actually, let me restart this search. Sorry about that. options, enable. Okay, let me do my searching one more time. Okay, yeah, so this is just fine. So if I click on my search, again to the right side, I see that there's an indication of that file. So if I see that there's an indication, I want to do once again, dump selected file. So I'm going to click dump selected file. The plugin should run. Whenever the execution is complete, it should tell us, hey, it's done. My plugin indication goes away. Now if I click on open working directory, this is the directory of everything that we're working on. And then if I go to dumped files right here, dumped files, I see these are the two files that we dumped previously directly from the memory image. If I click on this stage file here, I want to open Notepad, because I know this is a batch file as a textual file that I can look at. So if I can open Notepad here, and I just copy these details over, we can determine that this is a file that was dumped. It was a simple batch file that said output these details to the command prompt. All right, I'm going to come back to this in 1 second. In our advanced analysis directory here, the Xavier, once it completes its analysis, there are one or more additional tabs that should open which specify, hey, I need you as the analyst to focus your attention on these details first. In the interest of time, I'm going to come to this specific tab here, in which I'm looking at the console details for whatever was shown on a terminal, which is really, really cool. So without being on the system at the time of execution, we can see these are the details or text that was provided to the user previously. And so if I scroll down, I see that there's a command line entry, there's history information that we can look at. We see this is a title of something that we said to search for, command details, and then the output. So the output of that is shown right here, just as we've seen. So in one instance, we're looking at the terminal text from a user, and then we're actually able to download the file here to do additional analysis that I've shown you from the data cross-referencing. If you're not sure of a specific file, let's say we only have an entry like this name that we want to look at, you can also do searching just on that specific string. And then again, we get additional context just of what we're searching for. So we can see that conhost, there's lots of hits to that specific file. That file was seen in command.exe, so we know something was executed from the command line, and then outputs was provided under this user context, C user SmartNet. And then once again, just like shown, we already downloaded this previously, but if you also wanted to download the memory of the image to search further, you can do that at this specific site. Let me come back. All right, so we've gone through this data cross-referencing, which helps us really quickly on a challenge or so in our investigation. Then there's user assist entries. I'm going to talk about this user assist entries just for a moment. Now, if I click on this, this is text separated values like TSV, text data. And now I'll explain the usefulness of this output and why this is shown here. User assist entries is a specific plugin that Volatile provides for us. But in particular, I want to show you two features here on why I care about this. One, you can click on the bottom here where it says export data. So I click on export data on a Windows machine. I can click on desktop or anywhere I want to store something. And this is user assist.txt. If I click to save that data, I can open this again, or anytime it says export, I can open that in a notepad file. And then it just allows me to do searching, I can zoom in, etc. as I require. But as I said, this is tab separated data. So this tab separated data, that means I can put this into a separate ingester program like Excel. So I open Excel on my computer. Excel opens here. I can copy and paste that data at this side. I'm now going to kind of expand the tabs here. Now, yes, this is a lot of data, but in memory analysis challenges, sometimes you're just given a raw image and told, find the malicious file, find what happened on the system, and you have no other particulars about, hey, where do I start? In an investigation, in the absence of any additional data, we always have to start from some point. And so user assist is a good place that you could consider starting from. Because what this provides for us, if I go to the right side, you have a focused time. And so my hypothesis is that something that is more important to the user has a longer time that it has been focused. And so this is where the user has directed their time frame. And in the absence of any additional details, if you're like, hey, here's an image, find what occurred inside the memory image. Okay, let me export that data to an Excel. I'm going to do a custom sort here. Custom sort by time focused. I'm going to order this by larger to smaller data here. I'm going to click OK. And then what I'm looking at is whatever executed for the longest amount of time for the user. And if I start to scroll down, you see that these are important aspects, that control panel here, explore.exe, the user open calc.exe. So I'm going to write down all of these things to investigate further, but at least this gives us an idea of what is important to the user at the time that something nefarious might have occurred. Here's the MS Paint that we saw in the investigation parameters. Let me scroll down, MS Paint again, and the amount of time it was executed on the system. Dump it was an important tool that was executed on the system that is highlighted for us. Solitaire, command.exe. This is where our command history comes from. So anytime I see these things, I'm like, I'm gonna have to search further for these specific things first to now begin to build my timeline. Command.exe notepad was important, and then here's WinRAR. WinRAR was installed on the machine, most likely by Firefox as the installer tool on the system, and so forth. But at least I'm showing you that, hey, here's where to start from, and here's what to look at. Again, SmartNet, user, desktop, that stage, that bat, it was also executed on the system. But I kind of focus these for you to kind of enhance your analysis and make us move even faster on the system. Okay, so very, very, very briefly, I've gone over what these framework actually looks like. This is the output that you'll just have to spend some time searching to determine what happened. All of the questions that I asked you in the slides, it's going to be included in the appendix, so you can see like how to solve this problem one by one. But at least you see the framework, the output, tables. I told you the tabular data. You can click on these various links to pivot directly into virus total if a hit is found that someone has updated or uploaded previously. If I scroll down as well, execution plugins. Let's say you want to look at each individual plugin directly, that's fine. These are the particulars of every single plugin that is executed in raw format for you. And then again, if you click on the bottom, you can pivot over into those specific tabs to see this is the raw data that now the Xavier tool analyzes further for us. There are many other features that you'll be able to click through and search in your analysis. But at least for now, this is a good place to see this is how to get started in this tool set. And with that, I'll turn back over to the presentation to provide closing comments as well as answer any questions that we might have here. Okay, just doing a mic check. Am I coming in all right?
Loud and clear.
All right, perfect. Thank you. Okay, so at this point, I'd just like to go into, if you want to learn more about this type of analysis and other individuals to learn from, I have a slide about them. But first, I provide free memory analysis tutorials and things that you can actually download to enhance your analysis in this type of work. And so if you go to the website, it's just solomonsanya.com. And that's the only stuff that I have up there at this time. And so you can see other analyses, other challenges, and then learn from other people to enhance your skill sets. Okay, and then at this slide, also I want to say if you really want to learn from other pioneers in this field, I definitely recommend you send a follow to these individuals. You can watch some of their talks, like Jessica Hyde. She's really good in this type of analysis that I've learned a lot from watching some of her videos. And so I'd recommend those to you as well as these links. James Smith, he has a good beginning to end portion of how do you conduct analysis. And so that's great, as well as cyber defenders. And so, any way that you want to get better, I try and provide those links over to you. And the last thing, if there are any questions, if there's ways I can write something specific to enhance your environment, maybe just let me know. All of this work here is open source. I'm not like, hey, it's a contract. It's all free. And so I just want to be able to help and advance the way that we conduct an analysis It's not easy, but hopefully this is helpful to you. Okay, I will stop here, and I see some questions in Slack. I will be in the Slack as well as the green room, and I turn it back over to you, Carlos. Thanks so much for your time, everyone.